The 2012 critical value FRQ. We are given a geometric graph again. It says let f be a continuous function defined on the interval from -4 to 3, whose graph consisting of 3 line segments and a semicircle centered at the origin is given above. Let g be equal to the function given by g of x equal to the integral from 1 to x of f of t. This is our area function. It's kind of a common piece of these critical value problems. When we're given an area function, remember we always, probably at some point in the problem, going to be asked about the derivative, and that derivative is going to use the second part of the fundamental theorem of calculus. The derivative undoes the integral and just leaves us with f of x. So this piece is going to be a very important part to work through the entire problem. So part A says find the values of g of 2 and g of -2. So for both of these, we are really using the area function. So we're just finding the area under a curve for both of these values. G of 2 represents the integral from 1 to 2 of f of t dt. 1 to 2 is going to be this triangle right here. Since it is below the x-axis, I know that's going to be a negative area. And then we just do the triangle area formula, 1/2 base times height. The base is 1, the height would also be 1/2. So the value of g of 2 is -1/4. If you get that, that is a point. If you weren't sure how we got the height, all you'd have to do is figure out the slope of this line, which is we have a slope of -1/2 for that little line segment there. And the other part, g of -2. G of -2, I plug the -2 into the top endpoint, and right away it seems a little weird to us, so we'll flip those around so we go from the smallest to the bigger point. But in doing that, we just have to make the integral negative. So -2 is here, and 1 is here. So we're finding all of this area that I've shaded in blue. Now the triangle, that's going to be positive because it's above the x-axis, and the semicircle is going to be negative because it's below the x-axis. So I've got a negative in front of that entire area. Well, this triangle has a height of it has a height of 3, a base of 1, so that's going to be 1/2 times 3 times 1. And then we'll subtract the area of the semicircle. Since this is a semicircle centered at the origin that has a radius equal to 1, so pi r squared is just pi, and we'll divide that by 2. If we want to simplify that, we will get pi over 2 minus 3/2. And that's the area under the curve from -2 to 1. If we get that correct, that is worth a second point for part A. Part B, it says for each of g of -3 and g double prime, let me say that again. For each of g prime of -3 and g double prime of -3, find the value or state that it does not exist. So this goes back to what we were saying earlier. If we know that g of x is the integral of f of t, then g prime of x is equal to f of x. And I can take it one step further. G double prime of x is equal to f prime of x. So that gives us the information we need in order to find both of these. So g prime of -3 would be equal to f of -3. Well, all I have to do for this is find the point on the graph of f. So here's -3. I find the corresponding y value. That's equal to 2. And we get a point for that. Second question. G double prime of -3 would be equal to f prime of -3. Now this is going to be a little bit more confusing to us. So the question is, what does f prime of -3 represent? F prime of 3 is the slope of the tangent line at -3. So this equals the slope of the tangent line at x equals -3. Well, if I were to draw in a tangent line at -3, it is equal to the line that's there. And so the slope of that line segment is the slope of the tangent line, and that slope happens to be 1. Because we rise up to and run to, so we get a slope of 1, so g double prime of -3 is equal to 1. And that is a second point for part B. So for A and B together, it's 4 points, and it's really just applying that area formula and the derivative of that. Question C. Find the x-coordinate of each point at which the graph of G has a horizontal tangent line. For each of these points, determine whether G has a relative minimum, maximum, or neither. Justify your answers. Okay, so a horizontal tangent line would indicate, for part C, that G prime of x, which we know is equal to f of x, equals 0. It's a horizontal tangent line, that is always that the derivative equals 0. So because we have this connection between g prime and f of x, all I need to do is identify where our function, which we have a picture of, is equal to 0. That happens at 2 places. This happens at x equals -1 and 1. And believe it or not, by having this equation, this g prime of x equal to 1, that's a point. Identifying these 2 potential places of local extrema, that's another point. Now on to figuring out whether or not these points are minimums or maximums. Now what happens at -1 is that we get a sign change of f of x. It goes positive to negative. That's an indication then that g has a maximum, because g prime, or f of x, changes from positive to negative. At 1, f of x stays negative. So that means there's no extrema here. No local extrema. So we just have to make a conclusion statement about that on the rubric. Both of those conclusion statements together are worth a point. So I'll write that down here below for part C. We would say G has a relative max at x equals -1 because g prime of x equal to f of x changes from positive to negative. We would also say that G has, we won't say that, we'll say x equals 1 is neither a minimum or maximum on g of x because g prime of x equal to f of x does not change sign. So all of that is worth a point. So from parts A, B, and C, we're up to 7 points for those 3 parts. That leaves 2 points for part D. Part D says, for x between -4 and 3, find all values of x for which the graph of G has a point of inflection. Explain your reasoning. Points of inflection, remember, refer to G double prime. So we're looking for where G double prime of x, which we know is equal to f prime of x, equals 0 or does not exist. That's a potential point of inflection. So on the graph, what are all of these potential places? So f prime of x equal to 0, that would indicate a horizontal tangent line on f. That could happen here. At 0, we would have a horizontal tangent line. So under f prime of x is equal to 0, that happens at x equals 0. For the does not exist part, that happens at 3 other points. It happens here because we have a sharp corner, here, and here. So all of these are sharp corners. So that means our potential points of inflection are at -2, -1, 0, and 1. Oops, 0 doesn't count here. -2, -1, 0, and 1 are potential. But this is not enough to say we have a point of inflection. We also need a sign change. We have a sign change at 3 of these. At -2, we go from increasing to decreasing. There's a sign change there, which means f prime goes from positive to negative. Here, it's decreasing the whole time. There's no sign change at -1. At 0, we go decreasing to increasing. And we also get a sign change here at 1, increasing to decreasing. So we can say as our answer that G has points of inflection at x equals -2, 0, and 1 because G double prime of x, which is equal to f prime of x, changes sign. And that's the big piece there, is that changes sign at each of those values. So you get a point for identifying these and a point for the explanation. And that is the end of this problem.